Welcome. Let's talk about our next set of problems that I want you to attack. So, in case you're not getting us, we're still on divisibility. I want to milk this for just a little bit more before we move on to our next topic. Specifically, I want you to just kind of come prepared. I want you to post a subset of problems. So I'm actually going to walk you through them. I'm going to ask you the questions and I'm going to give you some hints to get you thinking about them. So the first problem is theorem 2.18. We're going to assume that three numbers are integers. And if A divides M and N, respectively, then A divides the sum of those two values. We're going to deal with this in a little bit, but this situation, again, this is an if-then. So my recommendation is to go ahead and start with the assume the given part. So start with assuming this right here. You can restate this part and then assume that A divides M and N. And then you have to go from there to how can I show that A divides this? All right. So again, I'm trying to get you started in this process and thinking about it. All right. After that, we'll move on to actually our problem 2.19, which is the converse. Remember, converse means I simply switch the order. So if I took this and I flipped it, and while converses are not logically equivalent, just because it's not, it may still be true. So A divides M plus N, then A divides M and A divides N. Again, this is one where you don't know if it is true or not. If it is not true, you just need to find a counterexample. If it is true, you need to prove it. So one thing you could do, and again, this is going back, we often start by making a list of numbers, A, M, and N, and then making sure that A divides M plus N. So I pick three numbers where A divides M plus N, and then ask the question, does A divide M and A divide N? Then do another example, another example. If you find any examples that break it, well, there's your counterexample, you're done. If none of them break it, the question is, what is the pattern I'm seeing here? And can I leverage that to do this in general? So that is how we often think about these kind of problems. Then you're going to move down to 2.20, which again, we have three values, A, M, and N. We're going to say A divides M and divides N. And this time, instead of adding them, we're doing subtraction. So this should, if after you do theorem 2.18, theorem 2.20 should feel very, very similar because it's going to feel almost identical. You just have a minus instead of a plus. That's why I'm not doing it, because if I did it for you, then it kind of gives it away. Then I want you to switch to problem 2.21. Again, this is a problem. So this one's kind of interesting. A, B, and M are integers. You need to determine the following statement holds sometimes, always, or never. Ooh, that's different. So are there values for which this is true, but not all values? Okay, that would be sometimes. Never, it's never, ever true. There's never any situation that makes this work. And always, yeah, we got a problem. There's a reason sometimes is kind of valuable is when we have a sometimes, often in mathematics, we can then add another restriction to this if portion to restrict it to make sure that it is always true. So we like to know more than just throw it out. We want to know, can I manipulate it to make it? Now, at a certain point in time, you just go, I've added so many parts to the if. It's like if 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things are all true, then we get this one thing. Okay, that's kind of boring. That's not really useful. So we have to use this kind of judiciously. So here you're going to ask if the product of A and B divides M, then A divides M and B divides M. Notice both of them have to divide it. That's a key thing. Okay, so try this one. And if it is always true, you're going to give me a proof. If it is sometimes or never true, you're going to give me a counterexample. That's 2.21. The last one, the penultimate one I'm going to give you is 2.22. It is this, you A, B, and C. If A divides B and B divides C, then A divides C. This is called transitivity. It's a property we're going to use in other things. The question is divisibility a transitive property? You may have done this when we learned in discrete math. If A, then B, if B, then C, if A, then C. We get to jump all the way to the end. We're doing the same thing. We're just doing it now with division. See if you can handle this one. And then theorem 2.23, which is going to be your final one. I kind of like this. I don't give you the letters. So all these I'm giving you letters. Now it's up to you. The sum of any three consecutive integers is always divisible by 3. This is a theorem, so you already know it's true. You need to prove it. So again, what are my assumptions? What are the things I get to start with, and where am I going? I really am looking forward to the discussion board because your assignment this week is going to actually be from these problems, as well as the problems you did earlier in the other discussion board. I'm going to start moving that way so that more and more of your homework problems that you turn in are actually the same exact ones that you already worked on the discussion board. And that's why I'm moving away from telling you yes and no. It's rather to help you learn how to correct yourselves. My job, again, as in this class, if we're doing it this kind of class where we're learning as we go, this kind of learning requires me to be more of a guide on the side and less of the expert who is telling you everything. That means I have to pick out the right set of problems and I have to set you up. So that's why I'm trying to set you up with this video and giving you hints. And then on the discussion boards, I'm trying to jump in and help you out. So if you're kind of off, I'm like, hey, in your intro, go check this. Oh, you could have said this to make it a little more clean. I'm trying to give you little bits of pieces here and there because that is the feedback that will help clean it up and get you there. Good luck. Let me know what questions you got.